Hello class, Dr. Barnes here. Let's take a look at this question on exponential Fourier series. So here we're supposed to find the Fourier series for this impulse train function, that is the waveform is given to us. Okay, so the impulses are given to us. Okay, so impulses are occurring at 0, 1, 2, minus 1 and minus 2. Okay, so this is an impulse train function, and this is how we write an impulse function. Okay, so the impulse function is what? Delta of t minus what? K t naught. Alright, so basically here, this place is our t naught, and this place is our 2t naught. Okay, alright, and this place is our negative t naught, and this place is our negative 2t naught. Okay, this is how this question actually, this is how this question actually is like. Okay, alright. I first introduced the 1 and 2 just to show you, but the question is actually like this. So this is the impulse train function you're supposed to deal with. Okay, and normally it will go this way, it will go this way, on and on and on like that. So let's say if k is equals to 0, then we're going to have delta of what? T. If here is 0, then it becomes a delta of t. Okay, and delta of t here, that means that t is equals to what? 0, and that is what? This 0, which corresponds to this particular one, this particular impulse. Now let's say if k is equals to what? 1, then that means that we're going to have delta of what? T into what? Minus what? T naught. Okay, and that means that t is equals to what? T naught, which corresponds to this impulse. Now if k is equals to minus 1, then we're going to have delta of what? T minus what? T naught. Okay, which is the same thing as what? Delta of what? T plus what? T naught, which corresponds to t equals to minus what? T naught, which corresponds to this one. Okay, so it goes on and on and on for all the impulses that are within the train. Okay, so now this one, so now in this case, our x of t becomes this impulse train function, which is delta of what? T minus what? K t naught. Okay, that's our impulse train function. Okay, so now here we're supposed to deal with the exponential Fourier series. We're supposed to deal with the exponential Fourier series, and we know that for exponential Fourier series, okay, our x of what? T is equals to summation infinity, n is equals to minus what? Infinity. Okay, cm into e minus j n omega naught t. Okay, so that is the standard that we have to use. Okay, and this one normally occurs for the interval t naught. Okay, less than what? T, less than what? T naught plus what? T. Okay, occurs for this interval. Okay, so now in this particular question, our main activity will be to be able to determine our Cm. But how can we determine our Cm? Before we can determine our Cm, we must make a certain assumptions of the impulse train that we have. Okay, to be able to use the exponential Fourier series to solve it. So this is the assumption that we will have to assume to be able to solve this question. So now here is what? X of t. Okay, and then I have to assume that this impulse, okay, this particular impulse has a certain length and breadth like this, and here is what? 0, and then this is the next one. Okay, and it's what? T0, and then it continues like this, and this one, let me represent that one also here. And that is what? Minus what? T naught. Okay, so now, and then the rest will continue what? This way. Now, let's say that these ones, okay, how can we deal with them? Okay, so now here, I can say that if here is 0 and here is what? T naught, then this place has to be what? Minus T naught over 2. Okay, and this place has to be what? Positive T naught over what? 2. And this place, I will assume my own what? My own coordinate for it, which is minus tau on 2. And here is what? This one is what? Tau on what? 2. Okay, so you know that before I can solve any question by exponential Fourier series, I must know the period. Okay, so that means that I must determine the period for this particular impulses or pulses that I have. Okay, so you see that the period can be from here to here, but I don't know the coordinate for here. Okay, I don't know the coordinate for here, so it's equal for me to choose. So it's equal for me to choose here and here. Okay, it can also be from here to here, but I don't know the coordinates for here. It can also be from here to here, but I don't know the coordinates here. Okay, in that case, I'll choose from minus T naught on 2 to T naught on 2. Okay, so because if here is 0 and here is T naught, then the middle will be what? Minus T naught on 2. If here is 0 and here is T naught, the middle will be what? T naught on 2. So I'll choose my period to be here. So this is my period, which is what? T. So what is going to be the value of T? The value of T will be what? Minus T naught to 0. That is what? Half T naught. And 0 to what? T naught over what? 2. That is what? 1 T naught. So it's equals to what? T naught. Now, let us see. It is equal to what? T naught. Okay. So now, let us also make certain assumptions. You see that this particular pulses that I have, they are bigger as compared to this one that I have. Okay. So in that case, how does this small pulses become big pulses like this? Okay. Okay, so these big pulses can become small like this. Okay, if let's say here, let's say my area is what? My height, my value here is A, my height here, or my value here is A. Okay, then what will be the area of this what? Pulse. Area is what? Length times breadth. So if here is, let's say, the length, what is the breadth here? The breadth here is what? Minus tau on 2. Here is tau on 2. So the breadth here will become what? Tau. Okay. Then what will be the area of this one? Then the area of this one will be equals to what? A tau. Okay, is equals to area. Because length times what? Breadth. Then when does this big pulse become this small line of pulse? This big pulse will become this small line of pulse if my tau is approaching 0, if my tau is what? Approaching 0, in that case my A tau, my area will be approaching what? 1. Will be approaching what? 1, because it will be left with only what? With only the height. Okay, with only the height. Approaching what? 0 means that it is not actually what? 0, but it's so becoming what? Like 0. In that case, it will just, if my this one, if my tau is actually approaching 0, then that means that this one, you see that means that the breadth here is becoming what? Very small, like what? This line. Okay, in that case, I'll be left with only what value may be here. In that case, I may be approaching something like what? 1. Okay, all right. So that is when this big pulses becomes what? Like this one. So that is the assumption what? Made. Okay, so now we shall proceed from this one. So whenever you make that assumption, then what you mean is that now it's these big pulses are now turning into what? The impulses that we have what? Over here. So now here I will write turns into impulses. impulses. Okay, so now this one now becomes this one. So that's the assumption. So now, having known this one, we can go and on and then find with our Fourier, exponential Fourier series. So now we know that Cm is equals now we know that Cm is equals to 1 over what? T into what? Into our period, which is what? Minus T naught to T naught. So minus what? T naught on 2 into what? T naught on what? 2. Okay, into what? X of what? T. X of T into what? Into E minus J n omega naught what? T. Okay, and this is always for what? T naught less than T less than what? T naught plus what? T. Okay, so now if I should put in my values, then my variables, then I'll get 1 over what? What was the period? My period was what? T naught. Okay, T naught. So what? T naught. Okay, and then what is my x of t? In this particular one, you see that the x of t becomes what? A. Becomes the A. Okay, and when is it really occurring? It's though it's from my period is from minus T naught on 2 to T naught on 2. My points are occurring at what? Minus tau on 2 and to what? To tau on 2. You have to be very mindful of when your actual pulses are occurring. Minus tau on 2 to what? Tau on 2. So here I have minus tau on 2, and then here I have tau on 2. Okay, into A, into what? E minus J n omega naught what? T. Okay, the T. Alright. Okay, so this is actually equals to A over what? T naught. A over T naught into what? Minus tau on 2. Minus tau on 2 into what? Tau on 2 into E minus J n omega naught what? T the what? The T. Okay, so this is the function that we're going to have. So now from here, we have to integrate this particular function. Okay, so let's see how we can do that. Okay, so now how I can do that is that if I integrate that, I'll get A on J n, okay, minus n omega naught into what? Into T naught. Okay, into T naught into E minus J n omega naught into T naught. Okay, like this. Okay, and then here are my limits. Minus tau on 2, and then here is tau on what? 2. Okay, so now what I want to do again is that I want to take this minus what? Inside. Okay, so that I'll have A over J n omega naught what? Into what? T naught. Okay, and then I'll have here minus E minus J n omega naught into what? T naught. Okay, here is minus tau on 2, and here is tau on what? Tau on 2. Okay, so this is what I'll have. So now, if I have this, now I can say that I can have A into J n omega naught into what? T naught into minus. Okay, so here I can have E minus J n omega naught into what? Tau on what? 2. Okay, minus E minus J n omega naught minus tau on what? 2. Okay, so I can say this. Okay, so now if I have this, then I can actually say that A over what? J n omega naught into what? T naught is going to give me, if I should, let me bring this one here. Okay, because this one is here. So now if I should multiply through by this, okay, but let me just go another step before I come to that. Minus J n omega naught into what? T on 2. Okay, minus E, Okay, so here negative become positive. Okay, en omega naught tau on what? 2. Okay, okay, so this is what I can have. Now, if I should multiply through by this one, I'm going to get a over what? Jn omega naught into what? T naught into multiply through by this negative. Okay, I'm going to get E minus, okay, I'm going to get Ej, okay, Ej n omega naught into what? Tau on 2, okay, and then this one will become positive, so it has come here, and then this one will become negative. Minus E minus J n omega naught into what? Tau on 2. Okay, so this is what I'm going to get. Okay, so now what is going to be the values for for all these? Okay, so the values for all these, we're going to have it. Okay, so you know that we're coming from here, and then now I'm pushing it and going to the next step. Okay, so here we're going to have these values by considering the exponentials. Okay, so now here, if you have anything like this, okay, if you have anything like this, I'm going to show you something that you can do there. Okay, so what you can do there is that if you have a function which is what? Ejn omega naught into t on 2, okay, minus what? E minus Jn omega naught into what? Tau on 2. Okay, let's say you have these functions to deal with. Okay, so what you can say is that this one is equal to what? Cos n omega naught tau on what? 2. Okay, mine plus, okay, j sine n omega naught, okay, tau on 2. Okay, minus cos this one. I just finished with this one. Now I'm coming to this one. Cos what? N omega naught tau on what? 2. Okay, so minus, okay, what will happen is that minus, okay, because here is minus, okay, j sine n omega naught tau on what? 2. Okay, so this is what you're going to have. So you're going to get what? Cos n omega naught tau on what? 2 plus j sine n omega naught tau on what? 2. Okay, minus cos n omega naught tau on what? 2. Okay, plus j sine n omega naught tau on what? 2. Okay, so you see that this one and this one, they will cancel. This one and this one, they will cancel. And you'll be left with what? These two. And these two will be equal to what? 2j sine, because they are 2. N omega naught tau on what? 2. Okay, so then you'll be left with this one. All right? Okay. So now, having known that, let us proceed. So if you are proceeding, then that means that from this particular function that I have here, I'm going to have a over what? Jn omega naught what? Tau t naught, okay? Omega naught t naught, okay? Into what? 2j sine n, okay? n omega naught tau on what? 2. Tau on 2. Okay, so this is what I'm going to have. For what? I'm going to have this one for my Cm. Okay, so this is going to be my Cm value. Okay, so now what happens is that in this particular, when you get here, okay, here we have to introduce something called the sink. Okay, basically when we say sink, okay, it is sink is an in trig, okay, so it is sine theta over what? Theta, which is equals to what? Sink what? Sink what? Theta. Or let's say sine what? X over what? X is equals to what? Sink what? X. Okay. All right. So now we have to write this particular formula that we have we have to write it in terms of what? Sync. Okay, we have to write it in terms of sync. So now how can we write this one in terms of sync? Okay, to write this one in terms of sync means that we must write it like this, or we must write it like this, which are the same. Okay, so now what we have is that we have Cm. If I'm writing it in terms of sync, then I'm going to have see. Let me write this aspect what first. Okay, let me write this aspect first. So here, what will happen is that J will cancel J. Okay, I hope you can see. Okay, this J will cancel this J. Okay, so the J will be what? Eliminated. So here, let me write over here. Okay, let me write over here that I'm going to have A on what? N omega naught into what? Omega naught what? T naught. Okay, into what? 2 sine N. Okay, so sine what? N omega naught into what? Tau on 2. Okay, into what? Tau on 2. Okay, so basically, all right. So that is what I'm going to get over there. So the J, guess what? Eliminated. Okay, now I want to write this one in terms of sync. Okay, so in terms of sync, which is this particular one, I'm going to have sine N omega naught into what? Tau on 2. Okay, over the same thing, which is what? N omega naught into what? Tau on what? 2. Okay, so this one is in this particular format. Okay, but you have to consider this place. You see that this N has now come here, this omega naught has now come here. Okay, and then now you see that I have introduced this 2 has now come here, but this tau, you see that it is not anywhere here. It's not here, it's not here, and it's not here also. So that means that the tau must come what? Up. Okay, but already there is this A there. So now this A will be here. Okay, and now this tau has to come what? Up. Okay, has to come up. Okay, so here, let me put this one here. Okay, and then there's this T naught here. Okay, so if I write it in terms of what? Sync, this is what I'm going to get. Okay, this is what I'm going to get. Okay, so you see that this one here, okay, is the same thing as what? This one. All right, so how did I write it? Let me repeat it again for you to get it. Okay, so this is the sine. This is the sine. N omega naught on tau on T. So sine N omega naught tau on T. Now it's left with this part. So now this N is here. So he has come here. This omega naught is here. So he has come here. Okay. Now this 2, he has come here. Now this tau, I brought a tau here. That means that I must introduce what? A tau, so that it will be like the original equation. So I introduce the tau here. Okay. So now this A is here. And this T naught, he is here. As for this guy and this guy, they have what? Come here. And this guy, he has what? Come here. Okay. So basically, that is how you can actually do this. Okay, that's how you can actually do this. So now let's see further. Okay, so this will not be the end of our answer. Okay, so now let's say that you see that our original equation, we were coming from what? Impulse strain function, and the impulse strain function, actually the width, which is the tau, is almost what? 0. Okay, and then the area is almost only what? 1. So now let's say tau approach what? 0. If tau is approaching what? 0, then A tau will be approaching, like, let's say 1 for impulse strain. Okay, will be approaching like 1. Okay, so now in that case, what is going to happen is that if tau is approaching 0, then we're going to get what? If 0 is here, then we're going to get what? Sinc 0. Okay, we're going to get sinc 0. And sinc 0 is what? 1. Okay, and sinc 0 is what? 1, because we're seeing that tau is approaching 0. That means that this space is what? 0. So that means that this space is what? 0. This space is also what? 0. And this one is what? A sinc function. So it's going to be what? Sinc 0, because here is 0, here is 0. And then it's going to be what? So it's going to be what? Sinc what? 0. And sinc 0, the value for sinc 0 is what? 1. Okay, so now we know that sinc 0, okay, sinc, let's say sinc 0, okay, is equals to what? 1. All right, sinc 0 is equals to 1. In that case, if sinc 0 is equal to 1, that this part becomes what? 1. And then my Cm will now be equals to what? A tau over what? Over T naught, because the sinc aspect is now what? 1. But I am also saying that this AT in terms of impulse train function approaches what? 1. So that this place becomes also what? 1. So that means that this place will also become what? 1 over what? T naught. So that means that my Cm is equals to 1 over what? T naught. Okay, so my Cm is actually 1 over what? T naught. In that case, what do I get my my x of t to be? So now my x of t is actually equals to summation from what? Infinity, n is equals to negative what? Infinity. Okay, 1 over what? T naught into what? E minus j n omega naught what? T. Okay, omega naught t. Okay, and when did I get this answer? I got this answer by considering the interval minus t naught on 2 less than what? T less than what? Positive t naught on what? 2. Okay, so that is how I got this answer. Okay, so basically that is how you can actually solve this question. And then after you have solved it, then you come to what? Your magnitude spectrum. So how do you get your magnitude spectrum? So let's see how you can get your magnitude spectrum in this question. So now here, magnitude, okay, spectrum. Okay, so how do you get a magnitude spectrum? This is how you can get a magnitude spectrum. Okay, here T. Okay, sorry, if it's magnitude spectrum, it will not be T. Okay, here N. Okay, here N. All right. So here it's going to be okay. It's because it's magnitude spectrum. Here will be what? Mod C what? M. Okay, mod C M. All right. And then what will happen is that it's impulse train. Okay, impulse train. Impulse train, they have the same height. Okay, impulse train, they have the same height. So here is going to be, what did we get it to be? Cm was what? 1 over what? T naught. That was the value for what? Cm that we got. So everything will be what? The same height. So they will all be the same what? Height, because it's impulse what? Train. Okay. So let's say here is 1, 2, and then 3, and then it goes on and on. Okay. So here, here, here. Okay. So same what? It will be the same what? Height. Okay. Okay. So here minus 1, minus 2, minus 3, and it goes on and on. Okay. So this is what? Our magnitude what? Spectrum. Now they also want us to calculate what? The phase spectrum. The phase spectrum is the what? Angle. Okay. So here is going to be what? Cm. This is how you write it. Okay. And then here is going to be what? N. All right. So here, let's say here, what happens is that because our Cm is equals to what? 1 over T naught, it has no imaginary part, but it has only real part. In that case, the phase angle is going to be what? 0. Okay, the phase angle is going to be 0. So here is what? 1, 2, 3. Okay, so here is 1, 2, 3. So the phase angle is what? 0. It goes on and on and on. Okay, so it's going to be 0 because it has only real part. It has no what? Imaginary what? Part. Okay. Okay, so it's all what? So the phase angle of what? 0, because it has only real part, it has no imaginary part, and it goes on and on and on. Alright, so this is how you can simply solve this question.